Hey, it's T. I'm one of the geniuses at Ask Zylor. So let's just get started with the live session. So the first question we're dealing with is from grade 12 calculus and vectors question. So we're dealing with the vectors portion, and we're given 3 points PQR. There are 3 vertices of a parallelogram, PQRS. We're asked to find the coordinates of the remaining vertex of the parallelogram. So we're assuming S is somewhere over here. Right? So we have to find the coordinate of S. So what we can do is use properties of these vectors to find this coordinate S. Right? So what we could do is, we know this vector, that's PR. We know this vector is going to be RS. Right? But RS is going to be the same as PQ. So what we could do is, we can say PS is the addition of PR and PQ. Right? But how do we find PR and PQ? We have the geometric, the coordinates of each of those points. We can find the geometric vectors. So for PR, we're going to say P plus R. So those coordinates are going to be -2, 1. And R is going to be 4 and 3. Right. So I'm just going to add the x's, add the y's together to give me my PR. So, sorry, I'm going to subtract the 2 together to give me my new vector, my geometric. So that should give me 6 and 2. Yeah, so when I'm finding the geometric vectors, what I should be doing is finding the second vertex and subtracting from the first. So that was my first mistake. So I'm just going to do 4, 3, minus 2, 1. Right, so minus minus makes it a plus, which gives me 6 and 2. So my next vertex I need to find is PQ. So P and Q, my Q point is going to be -4 and -6 and 4. And so it's going to be minus my P, which is -2 and 1 again. So this gives me -4 and 3. Right. So now I have the 2 vectors that I can use to add up to give me PS. Right. So my PS is going to be PR plus PQ. And the 2 vectors are going to be 6, 2 plus -4 and 3. So when I add them together, I should get 2 and 5. So I found the vector from P to S. So over here, PS. Right? But we're not done yet, because we only found the vector, but we're asked for the coordinate. Right? So what we could do is PS is equal to the origin to S minus the origin to P. Right? So if this is my graph again, this is my P, this is my S. I can do the origin to S minus the origin to P will give me my PS. Right. So I know my PS already, so it's 2, 5. My origin to S is what I'm trying to find, so that's going to give me my coordinate. My origin to P is simply my coordinate of P, so it's -2 and 1. And I just need to rearrange to give me the origin to S. Right? So it's going to be 2, 5 plus -2, 1. So my origin to S is going to be 0 and 6. So that's my coordinate for S. It's going to be 0 and 6. So that was a pretty long question. So just to recap what we did, we are asked to find the coordinate of S. So what we initially did was found the vector from P to S. So we used the vector properties. So we know P to R. If we add that with P to Q, which is the same as R to S, is going to give me my vector PS. Right? And then I can use that PS to find the vector from the origin to S, which is the same as my coordinate. So in this case, it's going to be 0 and 6. So let's move on to part B of the question. So we're asked to find the measures of internal angles of the parallelogram to the nearest degree. So the parallelogram is going to look something like this. We have 2 angles. We have the obtuse and the acute. Right? The 2 acute are going to be the same. The obtuses are going to be the same as well. So essentially we need to find two angles. Okay? So let's call these points something. So let's say this is P. Our points were P, Q, R, S. So P, Q, S, and R. Right? So let's find the angle between P and Q and P and R. So the angle at P, essentially. Right? So we know PQ is equal to the vector -4 and 3. We know PR is going to be 6 and 2. So the magnitudes for PQ is going to be the square root of -4 squared plus the square root of 3 squared. Right? So that's going to be 16 plus 9, square root of 25 is going to give me 5. I'm going to do the same for PR. So I have 6 squared plus 2 squared to give me 40, so the square root of 40. I'm just going to leave it as an exact value. So then I found the values of this and this. Right? So what can I do with that? I can use that to find, I can use the cos, the dot product equation essentially. So it's going to be PR dot PQ is equal to the magnitudes PR, magnitude PQ times the cos between each of these vectors. Right? So we are interested in the angle only, so we're going to isolate for that angle. So cos theta is equal to PR dot product of PQ divided by the two magnitudes multiplied each other. Right? So then I'm just going to plug the values in. So the dot product between the two vectors. So my 2 points are going to be -4 and 3, and then 6 and 2. Those are my vectors for PR, PQ, and the magnitudes I found earlier. So it's going to be 5 and square root 40. And I just need to find the cos inverse of this entire term. Right. So the dot product will evaluate to -18. The bottom is just 5 times square root 40. So the cos inverse of this will give me the angle between PR and PQ, which is the angle at P. Right. So that should give me 125 degrees. So we found the obtuse angle. So in a parallelogram, we found this angle. So to find the other angle, we can simply just do 180 minus 125, which gives me 55. So I have the acute angle as well now. Right? Why can I do this? It's because all the angles on the inside add up to 360, and we know that both the obtuse angles are 125 now. So to find the acute, I just do 180 minus 125. So the final part of this question is asking me to find the measures of the angle between the diagonals of the parallelogram to the nearest degree. So again, I'll redraw the parallelogram. We have P, Q, S, and R. The diagonal, so this line and this line. The measures of the angle between the diagonals, so I can find this angle or this angle. So my diagonals, I have the vectors as PS, or my diagonal as RQ. Right? This diagonal or this diagonal. So we found the PS earlier, the vector, to be 2 and 5. So what we could do is essentially find the two vectors and do the dot product, use the dot product to find the angle again. Right? So let's find RQ first. So that's going to be the origin to Q minus origin to R. So when I subtract the two, I should get the diagonal. So that's going to be negative 6 and 4 minus 4 and 3. This evaluates to negative 10 and 1. This is my RQ vector. Right? So I have the two vectors. I can use the dot product again, so I need to find the magnitudes first before I proceed. So that's going to be the square root of 2 squared plus 5 squared is going to be the square root of 29. And the square root, the magnitude for RQ is going to be the square root of negative 10 squared plus 1 squared. Right? That's going to be 101. So now we have all the terms we need to evaluate the dot product. So we do PS dot RQ is equal to the magnitudes of each of these vectors times the cos between the angle of the two vectors. Right? So once again we have to isolate for this angle. So we say theta is equal to the cos inverse of the dot product divided by the magnitudes of the vectors. Right? So the vectors itself are negative 10 and 1, 2 and 5, and then we have the magnitudes as 101, square root of 101, and the square root of 29. Right? I just need to cos inverse of this. So this ends up being 106 degrees, so that I can say is the angle between the two diagonals. Okay, so we're going to move on to the next question. So it's another calculus vectors, a vectors question. It's dealing with vectors in 3D space. So we're asked to describe the method you would use to plot the point negative 3, 5, and 7 on a piece of paper. Right? So there's many ways of doing this. The easiest way, I would say, I'm just going to rewrite the vector down, the point negative 3, 5, and negative 7. So my x value is negative 3, the y value is 5, and the z value is negative 7. Okay, so the method I usually show is that you just walk through each of these points, meaning I'm going to first find where negative 3 is, then from that point go to the y is equal to 5, and from that point go to z is equal to negative 7. Okay, so let's find x. So this is my x-axis, y-axis, and this is my z-axis. So in my x, I'm going to find where negative 3 is, and I'm going to go to that point. And from that point on, I'm going to find where y is equal to 5 and go towards that. So this is my y-axis, so I'm going to go 5 units in the positive direction. So I end up over here at C. And then I'm going to go z negative 7, meaning I'm going to go negative 7 units in the negative direction in the z-axis. So z is going up and down in this case, so I'm going to go down by 7 units. I end up over here. Right? So it's kind of like a walkthrough between each of the coordinates. I go to my x, which is negative 3, I go to my y from that point on, and then I go to my z. So the second part of the question is asking if the c vector is equal to the a vector times b vector, what can be said about the dot product of c and a and c and b? So let me rewrite this. So c is equal to a cross b. It's a cross product. So if we get the cross product between a and b, which gives me a c vector, right? So the cross product means that c is going to be perpendicular to both a and b, right? So what do we know about the dot product between two perpendicular vectors? So if we take the dot product between a and c, that should give me 0. Right? The dot product between any two perpendicular vectors is always going to be 0. So then if I take the dot product between A and B, it should again give me 0 because C is perpendicular to both A and B. Okay. So the last part of the question is asking if U is equal to 6, 1, 8 is orthogonal to U is equal to K, negative 4, 5, determine the value of K. Okay, so orthogonal means that they're gonna be perpendicular to each other, right? So we're given two vectors. So let's say, I'm just gonna rewrite this. I'm gonna say U is equal to the vector given, which is 6, 1, and 8. I'm gonna use a different notation for the second vector, which is K, negative 4, and 5. So these guys are orthogonal to each other, right? So we're asked to find the value of K if they're orthogonal to each other. So like I said before, if two vectors are orthogonal or perpendicular to each other, then the dot product between them has to equal to 0. So U dot V has to equal to 0. So let's evaluate the dot product and see if we can solve for what K is. So 6 times K plus 1 times negative 4 plus 8 times 5 is going to be equal to 0. Right? So then I can isolate for my K value because that's the only variable I have. So I can say 6K is equal to negative 4, which becomes plus 4, and move the 8 times 5, which is 40, to the other side, so minus 40, which leaves me with K is equal to 4 minus 40 ends up being negative 36. You can divide both sides by 6 to isolate for K. So this gives me negative 6 as my K value. Right, the main idea behind this is that you find the dot product between two perpendicular vectors is going to be 0. Orthogonal and perpendicular are the same meaning. They both mean that two vectors are perpendicular to each other. Okay, so let's move on to the next question. So this is a grade 11 functions question. So it's dealing with ambiguous case. So we'll be most likely dealing with the sine law. So determine whether it is possible to draw a triangle given each set of information. Sketch all possible values, A and C. We'll be doing A and C. Okay. So let's start with A. So we're given A is equal to 5.2. So let's draw a small triangle for this. Right. I'm going to say this is A, which is 5.2. I'm going to say this is B, which is 2.8. And the angle opposite to B is going to be 65 degrees. So this is big B, this is A if that exists, and this is C. Right. So what we have to do is find what the vertical height is of the perpendicular height. Why do we find that? Because if my height is going to be bigger than my B value, that means my B, this side is never going to touch this side. Right? So let's go ahead and find what this H value is. So that H, we can treat it like a right angle triangle, and we can say the sine of 65 degrees. Right, so the opposite over hypotenuse. So the hypotenuse is 5.2. Right, so sine 65 times 5.2 is going to give me what the height is, which is 4.712. Right, since my height is bigger than my B value, right, since 4.712 is bigger than 2.8, this B side length can never touch this side over here. Right, so we have no triangle. Let's call this side C to make it more clear. Right, so the B side length will never touch the C side. Okay, so let's try another question. So let's try part C. Okay, so we basically have a similar triangle but with different values given to us. Right. So we're going to say A is 8.5, we have B as 5, and the angle is now 36. So once again, we should be finding what this H value is, what the perpendicular height is. So we're treating it like a right angle triangle again. So we can do sine 36 again, times 8.5 to give me my height. Right? Just to clarify where I'm getting this, I'm using sine 36 degrees is equal to opposite over hypotenuse. My opposite is my height. My hypotenuse is 8.5. Right? Opposite hypotenuse. So my height ends up being 4.99. So now I'm going to compare that with my B value. So my height is approximately the same as my B, right? My B is 5. So that means it can only touch the side length C exactly once, which is going to be the same as my height. Right? So we have exactly one triangle. Okay? So the reason we're doing this is to essentially show that this perpendicular height is the shortest possible distance from this vertex to this side length of C. Right? If my side length B is shorter than that, then I can't have a triangle because H is the shortest possible side. If my B is exactly height, that means it's the shortest possible height, so I have one exact triangle. If my B is bigger, then I can have two possible triangles because I can have one going towards my A side and one going away from my A side. So let's move on to the next question. So this is a grade 9 math question. So we're asked to find a simplified expression for the volume. So let's go ahead and write the equation for the volume. So volume is length times width times height. Okay. So let's say 3x is my length, x is my width, my height is 6x minus 1. So I have 3x times x times 6x minus 1 as my volume. Right? So now we're asked to simplify and expand. So what we can do is treat two brackets together, as in evaluate two brackets at a time. So 3x times x gives me 3x squared times 6x minus 1. And then I can use the FOIL method. It's basically distributing each term into each term in the second bracket. So I'm distributing 3x squared into 6x to give me 18x cubed, and then I'm distributing 3x squared to the negative 1 to give me minus 3x squared. So this is a simplified expression for my volume.